Hello everyone. Welcome back. Hope you guys' end of the semester is kind of going well, wrapping up smoothly. Today we're going to be finishing up some of the topics that we went over in the last lecture about networking, and we'll dive a little more into Codable. But to start off, let's do a quick review of what we went over last lecture. And so the first question is, which of the following is not a type of the HTTP request? So I'll give you a few seconds to think over it. And so the right answer is create. And so we went over get, delete, and post. And usually if you want to make a request to create an object or something like that, it's usually done through a post request. Create is not just is formally not one of the methods of an HTTP request. The next question is, what is JSON? You'll probably be dealing with JSON a lot throughout all of your networking stuff, so this is a pretty important one. But I'll give you a few more seconds for this as well. And the answer is dictionaries with key value pairs. Pretty much it just standardizes, it's essentially a dictionary the way you would use it in Swift or Python or any language, just using a primitive data types. Great. So the first new topic that we wanted to go over was on closures. And so this is actually something you may have seen around, especially in the networking code, maybe even in the last lecture. But a little more formally, closures are self-contained blocks of functionality that can be passed around and used in your code. And essentially what this means is that it is a function that can be passed around as a variable, if that kind of makes sense. It's an anonymous function, if you're familiar with that term. But basically they're functions that aren't formally defined. Usually we do to define a function, we do func, then the function name, all the parameters, and then return type, blah, blah, blah. But it's a little different for closures. So you'll see here we're actually, in the first line, we're actually creating a variable. So we're calling let add two numbers closure. And so a closure is being stored as a variable, and that's how we're passing it around. But the rest of it has very similar syntax to creating a function. And so it takes in a tuple, or just actually not a tuple. It just takes in two integers and returns an integer. And then after the equal sign, that is essentially it's the same syntax as a function. We'll see that we have to name the parameters that we pass in just so we're able to access them. So we name them first and second, and then after the in, the rest of it is pretty much all the logic that's going to be run whenever this function is called. And the way you call a closure, or use a closure if you want to say that, you essentially call it the same way you would call a function. But you'll notice that we do not have the same function name, blah blah blah. It's not declared the same way. And so this is actually very commonly used for passing around a function to another function. So for example, if you've used the map, filter, or sort functions, they tend to apply a function on every single element of an array. And so let's say you have this list, let list equals this array, and you want to apply some sort of mapping of seeing if the variable, or if the value at each index is positive or negative. And so you create a function that returns true or false based on whether it's positive or negative, and you want to apply this to every single function. You then pass it into the function map. And so what map does is it takes this closure and runs it on every single element. And yeah, we'll go into a lot more on this in networking, but you'll see here, this is in our old code. You might be familiar with this, but pretty much what our networking code did was it took in the response JSON and it converts it. But then after we get the response, we want to be able to pass it back or call some sort of function on it. Because the way networking works is it is all asynchronous. And so it takes time for each response to get back to iOS. And so one big thing on this is that like when networking code is being called, the iOS or the client side never wants to wait for the response. The app should be able to like function and continue to do its computations on like any other stuff while the server is handling, because the server is a different machine, it's a different entity. It doesn't need to be waiting on that because they're handling the requests on different processes. And so the way we handle this is we pass in a closure. You'll see here it says completion at escaping, and then you pass in a list of courses, but that completion variable is essentially the closure block that we want to run after the response is successful. And so you'll see here in the code, after we convert the JSON to the array of courses, we then call the function completion and pass in the list of courses, and then on the wherever the function get classes was being called, it'll run that block of code. This will all make a lot more sense once we go into the examples. But yeah, after we get it, notice that there is the at escaping keyword. A small note on this, you probably won't need to know the nitty-gritty details on this, but generally a closure is set to escape a function when it's a parameter to a function and is called after the function returns. And so like the courses are being passed after the function get classes is like completed, just because the Alamo Fire request is also asynchronous. And so that's why we use the at escaping. You'll notice we did not have the at escaping here, and that's because it's just not being used after the function returns. Dope. So some more review on just general networking stuff. We use networking across all apps to retrieve, update, delete, or add data, pretty much modify any database or like access any outside information. Like if you want some global data storage, or like, I don't know, just for example, like if you want to store all your courses on like one data center instead of storing them locally on the iOS side, you would just set up some sort of database, and you would use networking to access that information. And so this is pretty much used in every single app that you use. Like Spotify, you delete a song from a playlist, add a song. Any social media app, Instagram, Facebook, you're accessing their data centers through network requests. And it's best to avoid hard coding data, especially if you want to have an app that has consistent data across like several different users. The different apps will not be communicating to each other, rather they'll be communicating to one data center. And so for passing in information to network requests, sometimes like for example in a login request you want to pass in like the email and password, or maybe some search requests you need to pass in like a query string. The way we do this is by passing it in through certain encoding methods. And so one very common one for GET requests is just passing it through the query string. And so this is just being explicitly passed into the request string. So you'll see here after the ampersand, we pass in every single, or usually there's like a question mark, not sure. But yeah, you can just pass it directly into the query string by separating each variable and value or key value pairing by an ampersand. And most networking libraries will handle this for you, but these are essentially like what this maps to. And then another way to do this is you can pass it in through the HTTP body. So this is not going to be exposed directly on the query string. or like on the query itself, but it'll be passed in as like extra information on the network request. And so we could do the same thing, pass in a username and password. And this tends to be a little safer, especially for passing around sensitive information. You do not want to be like, you don't want to have the username and password directly inputted into the like the query string or whatever, like the URL. And then lastly, we have JSON encoding, and it's pretty much just passing around the dictionaries of like primitive data types. It's quite similar to HTTP body, and it's very commonly used for post requests. And just a side note on like APIs, you'll hear this term being used a lot. So it stands for Application Programming Interface, and it's sort of like a menu containing like all the functionalities or operations an application can use to interact with another application. So, for example, like Google has its Google Calendar API, and so it has a list of like all the possible HTTP requests, all the parameters it needs to be passed in for each one, and the responses. It pretty much outlines or defines like how you can interact with this interface or endpoint. And yeah, so like jumping into how exactly we decode the responses. I know you guys went over some codable stuff, but in the last lecture, but we pretty much just make the request, and then you'll see that like this is a response that it gives us. But we want to decode this into the JSON model, or like from JSON to our course object or whatever models we have inside of our app. And so the way we do this is just conform to codable. Essentially, codable tells the JSON decoder object how to decode the JSON into our custom object. And it takes away a lot of the boilerplate code of just like accessing JSON at this key equals this variable, blah, blah, blah. It tends to take away a lot of the boilerplate code pretty much. And you'll notice that all the field names and types match exactly. And this is one key component to how like all the JSON decoding runs smoothly. If they do not match up, then you'll most probably run into some errors. Dope. And we'll go through a demo just to like make this all make a little more sense. But yeah, to quickly recap, this is this is pretty much where you guys left off. This code should be posted online as well. But last time we had a function for get courses and used Almafire. We had our course object set up and our view controller. And so the first thing we're going to do is we're going to take a look back at our classes data model, or like the JSON that gets returned whenever we hit this endpoint. You'll notice we have the class set up for a course. And we have the name, code, instructor, and enrolled, name, code, instructor, and enrolled. And the types are all the same: string, integer, string, boolean. They all match up. But now if we want to make this conform to codable, all we really need to do is just conform to codable. This pretty much just says if every single field in here has a type that conforms to codable, then course will be able to conform to codable, and now you can just decode with ease. Perfect. So now we have the model that would be able to decode this. But now you'll notice this is being wrapped in a classes variable, and it's passed in as an array of course objects. And so what we'll want to do to be able to decode this courses object, we want this to conform to codable as well. And we need to make sure that this variable name aligns as well as the type. And so we'll create a variable called classes, and it will be an array of this type. And so for our case, this is going to be a course object. And so hopefully after this compiles very quickly, you'll see that it is able to conform to Codable because the inner types all conform to Codable as well. Perfect. So now we have our model for this, and very similarly, we're going to do the same to be able to unwrap the data field. And so we're going to do courses response. We're going to make this conform to Codable as well, and we're going to have data. And the type of this is going to actually contain this type, which we just created. So it's going to be a course object, or a courses object. Perfect. So now we should have all of the necessary models to be able to decode our response. Now, if we go into the network manager, we'll have a very similar setup to what we had last time. Wait, I don't know why I'm spacing on this. Let me quickly pull the function. But yeah, what we're going to be doing is, okay, so we're going to do almofire.request, and we're going to use this autofilled function, but we want to pass in the URL. So for our get courses URL, we're going to be hitting mindyloo.github.io, and we just store that in endpoint, and this is going to be a get request. We're just getting data in general. Yeah, this is usually defined by the endpoint itself, what kind of request it wants to handle. So for this case, it is a get request, and we're actually just going to erase the rest of this. The rest were optional parameters, such as like possible query parameters, encoding if you want some different encoding, or headers. But these are not necessary for now. And we're going to do .validate. Sorry, I'm forgetting again. .response data. And so you'll see here we have CompletionHandler. And now we want to pass in, like we're, how do I explain this? So now we're using the function response data, and this takes in a completion handler, which passes in a response object, which is just the response of the request. And so now we want to access our response object by doing response.result. And so on our response.result, we have two different types. It can either be successful or an error. This should all be stuff as well we've gone over before. We're going to do .failure, error, error.localized description. Sorry, I'm just writing through some like more boilerplate code. This is just for getting access to our responses data. And so here we have, here's where we're gonna want to actually decode the data. And so the first thing we're gonna do is, if you remember from the slides, we want to create a JSON decoder. Decoder equals JSON decoder. And this is going to be the object that helps us decode the JSON response into our courses object. And so now in here, we want to, I'm just going to copy over this code, but pretty much we want to decode the data that we got from here and put it through the course response like decoder, and it's going to be using Codable to decode the information. And so what this is going to do is, or what we're going to do is we're going to wrap this in an if-let. We're going to unwrap this by calling try. We're gonna use a decoder.decode course response, and we're gonna pass in the class's like type itself to the decoder, so the decoder knows what kind of model to be using for this decoding. And we're gonna pass in data as the JSON object that we're decoding from. And if we decode this within this block, if this is successful, and you'll notice here we have this optional chaining. This is saying like if the decoding is does not create an error, then it'll unwrap to courses data. And in here we can just directly print courses data, and we can actually access the classes by doing courses data.data classes. Perfect. Yeah, so classes should have the type should have the type an array of courses. And so actually if we do this and we run this, oh sorry, one quick thing we need to do before we run this actually, oh, we are calling it, perfect. Get classes, oh, we never actually called it. So we're gonna do network manager dot get courses. This is going to basically be calling the function we just filled out, very similar to how we did last lecture as well. But if we rerun this now, we'll see what it printed here. It's a bunch of L6 starter.course objects, and it contains all the information, name, code, instructor, enrolled for each of these. And it matches up one-to-one with, if I have one-to-one with all this information. Perfect. So now we have our very basic network manager, or like get requests, but now we want to be able to render this in our table view, right? And so the way we would do this is by adding a completion handler. So what we want to do is pretty much say, after this request is done, we have all of our data, we want to pass this class's object back to our view controller. And the way we would do this is by adding a completion. And we want to have this of type course. I think this is the correct syntax. Only applies to function types. Void. Sorry, let me double check. Perfect. So our completion handler is going to have the type, or it's going to have a type of being a closure, and that closure takes in an array of course objects and returns void, or just like doesn't return any information. And so now we want to be able to call that completion, and to do so, actually one thing I'll highlight, you'll notice that this type is also the same here, and so it takes in this array of courses. And the way we call it is the same way we call a function, and so we'll just call completion classes. If we try and build this, we'll actually get an error because we have not done, we have not added the proper field for this. And so what we can do here is actually some nifty Swift syntax. If you have a completion handler, like a closure, as the last parameter, you can just pass it in as like a function. And if you remember, we have classes in. And now if we do this instead and remove the print statement here, sorry, let me quickly go over what we just did. So we created this completion handler, and we're calling that completion handler after the data gets decoded properly. And now we're passing in a completion handler to that function, and we're saying after this data gets decoded, just print it. And so this should run fine. And after the request is made, it prints out our data. Now what we want to do, and actually we want to populate this table view that we have with this course's data. And so you guys should already have the code to configure the courses. It should be hooked up properly. All we want to do is update the courses array. And we can do self.classes. Whenever you access a local variable or a variable, an instance variable, a variable that would require self, and usually we can do that implicitly. Whenever it's within a closure, you have to do self dot. Has something to do with like references and pointers. Not too important, but just remember to use self whenever in an enclosure. And so we're setting self.courses equals classes. And the last step we would need to do is refresh the table view. And so to do that, if you guys remember from our table views lecture, we can just call self.tableview.reload data. I'll run this just to see, but one note on refreshing table views or your UI. Actually, it did not give us an error this time, but you'll see it actually did not update anything. One thing we always have to remember to do whenever updating the UI within a closure is you have to make sure that it runs on the main queue. Pretty much what this is saying is like this main queue is of the highest priority, and has to do with like Apple's like inner threading mechanisms. But pretty much you always want to update the UI on the main thread or of highest priority. And so hopefully this runs properly. It did not. Why did this not run? Sorry, let me quickly debug this. Why is this not running? Is it being added? Content view to add. View to add subview, set up constraints. Right. Oh. I'll update this in the starter code, so this should not be an issue. But one thing we always need to remember to do is set the auto resizing masking constraints. Perfect. So you'll see that our table view is now being populated with the correct data. It has a name. I don't know what the fields are exactly. Name, instructors, course number, or course code, and then the color corresponds to enrolled or not, I believe. Yeah, enrolled. Perfect. So now we have our simple GET request working. Now let's delve a little more into the parameter encoding. And so the next one we want to go through is the login. You'll remember that this was, we want to pass in email and password to the actual HTTP request, but we also want to do this in a fashion that is not explicitly exposing it to the URL. And so we'll do very similar. URL this time is going to be the post endpoint. And actually, let me quickly run through the request we're making. This is the API spec for the next request we're going to be making, and their endpoint is /API/login. And you'll see here the login is a post request. And we also need to be passing in email and password in the body. And so this is all information that we're going to be using to determine like how to pass in our information. But for here, we want to do post and parameters. I'll keep this open for now. But we want to be able to pass in some parameters. And so we're actually going to, what are we going to do? We're just going to create a dictionary that maps a string Sorry, I can't spell. My I key is broken. Usually for parameters, you can just do string to any. Wait, what? It's capitalized. And we're gonna fill in this information here. And so we're gonna map our first parameter that we want to pass in according to the spec is gonna be email. And then its corresponding value will be the email that we pass into this login function. And then same thing for password. The key is going to be password, and then the value is going to be password as well. Perfect. So now we have our parameters dictionary, and we just want to pass this directly into here. And then very similar, validate response data. So now we have response. Sorry, this is all boilerplate code. You can you can pretty much copy and paste similar stuff. But for pretty much all the Alamo Fire responses, we're always going to be doing .validate, .response data. We get the response and then switch on the result, check if it's successful or not. And then in the success, when we unwrap the data, this is when we're going to have all the logic. I'm just going to do this just so it's not screaming at us. And .localize description. Cool. I'll give you guys a quick second to catch up on this. But yeah, very similar. This time we passed in the parameters, which we passed in as the body, if you remember from the beginning of the lecture. And then we're also making sure that this is a post request. And so now we are going to make the corresponding data model to handle this information. And so you'll see here the response here is just a token and it's a string. And so we will create a new file. And this is just going to be a new Swift file. And we're going to call this login response. And so we're going to create a struct login response, make sure it conforms to codable. I'm just copying and pasting this just so I don't misspell anything. But we're going to have a variable called token, and it's just going to be a string. And hopefully this should be everything we need, but perfect. So now all we need to do is do the same decoding that we had up here, just in the login. So we can actually just copy and paste our decoding here. Login token, or login response. And we'll pass in the login response object. And so now in here, what should be unwrapped is, make sure to instantiate your decoder object. But now the unwrapped login response variable has this type and contains our token. And so the next step, similar to how we did in Git courses, we will most probably want to pass that token back to whoever called the login function. And so we're going to add another completion handler, very similar code, but this time we're just going to be passing in a string as the variable to the completion. And so here we're going to do very similar things, pass in the login response. Actually, you can choose which one you would like, but for right now we're just going to do string. We just want to pass a token back. Maybe there's some other information in the login response that we don't necessarily need to pass back to our whoever called this function. So we're just going to do login response. Sorry, I don't know why this is bugging. Dot token. And so this should call the completion handler, and now whoever calls this login function and passes in a proper completion handler will have access to this after the response is done. And so if we go back into here, we're going to have a very similar setup. We're going to call network manager.login. We're going to pass in, we should store, yeah, we have email and password already stored on your starter code, and then password here, and then we want to pass in the completion. So now this time we're going to unwrap it as the variable token, and we're simply just going to print token, just to make sure that it comes up, and we should in theory see this token being printed. And so if we run this, we are already running the login function on startup. And so you'll see this is still running properly, and we get this token printed out as we expected it to. And so that's kind of a rundown of how you would pass in parameters into the request body and it's more common with post requests, but you can also do it with get requests. Perfect. So the next step we will want to go over has to do more with like chaining requests. And so we'll do this using the dog API, if you've ever used this before. How this works is if you go to random.dog, what this endpoint does is if you call /woof.json, you get a response that contains a URL. But now actually, wait, why are we doing this? But what we need to do after this is, wait, this is interesting. The way we load, okay, sorry, I'm gonna restart that. But so this dog API, if we call woof.json, it returns us a URL of a random dog image. And actually, if we go to this dog image, you'll see that it pops up here. But what happens is if we want to load this image into our app, you'll notice we don't have this stored in our assets. And so we actually have to make another request to be able to retrieve the data that is going to be used to render the image. This will make a lot more sense in a sec, but what we're going to do is make another get request to this endpoint, and we want to hit random dog /woof.json, and this should actually be already the dog endpoint. We're just going to copy the boilerplate code just because it saves us time, but the endpoint we're going to use is going to be dog endpoint. We still have the switch result, success, and we're going to want the decoder. Perfect. So now what we're going to do is we want to use the data. We want to use the data that gets returned here to be able to render it. And so as usual, we need a class to be able to decode this information. And so we're going to make another file called dog response. We'll call it that. And so we have dog response is a struct, conforms to codable, and then the fields we get are file size, bytes, and URL. In fact, we don't need to retrieve file size bytes, and so if we want to just ignore it, we just don't have to add it in as a field of dog response. This is going to be a string, and so pretty much like if this information is returned, all this will do is go into dog response and try and decode every single field in here and add it. But since it's not trying to decode file size bytes, it doesn't care for it and just ignores it. Perfect. So now we have this information. We're just gonna use the same decoding. We're gonna call it dog response, and we're gonna decode to dog response.self. And so now in here, we want to make the actual request to retrieve an image. So how are we going to do this? We have this dog response, we have the URL, and we want to make a second request to fetch the actual image from the URL. And so what we're going to do is we're actually going to call fetch dog image, and we're going to use dog response.url. After we fill this in, actually, let's fill it in first. So now we're going to write another function to actually do the fetching of the image data. And so what's going to happen is very similar. I think we actually hit the image URL as the endpoint this time. And it's just a very simple data. Actually, I don't know. We can mess around with that. But this time, what we're going to do a little differently is now when we make the request to image URL, we actually get the data, like this type, if I can expand this, is of type data. And we can actually directly use this data object to render the image. And so what we're going to do is we're just going to do lat image equals UI image, and one of the instantiators is using data, and we can just directly pass this in. And so now after this request gets made, we now have access to this image and want to return it. But notice, so we're going to be calling fetch dog image from within the get random dog response. But what the view controller is calling is just going to be network manager dot get random dog. And so we want the completion handler to eventually return this UI image object that we're going to use to render the dog image view. And so what we want to do is add a completion handler to this function first. It's going to be the usual at escaping. It's going to have type UI image to void. And we're just going to call that completion image. And so now whenever fetch dog, you'll see that this gave small note, this constructor will see that it actually had the return type is optional. So technically if the data is corrupt, then it won't be able to render properly. And so we can just directly wrap this in if let to make sure that if it's corrupted, then it doesn't try and call the completion handler. And now we want to let image equals we're just going to call this returned image. And then this completion handler, we're just going to store returned image from this completion. And so now we want to return this image in get random dog. So what we can do in here is do the same thing, add a completion handler, at escaping, I'm spacing out, sorry, UI image, and return void. And so now we can just, instead of doing this, we can call, actually, we can just call completion on that returned image. Or we can just call it on image, doesn't really matter. I was just doing this to be a little more clear on which one is being passed in. And so now get random dog will return the proper image. And lastly, we want to add this completion handler in here. And so we now have access to this image after the response. And so what we want to do now is update the dog image view. And so we can just do this directly by doing dog image view dot image equals image. And so this takes in the returned image and updates it. But like we mentioned a little earlier, we also want to make sure that we wrap this in a dispatch queue dot main. And so the reason for that is because we are updating the UI, and so we want to run this on the main thread. If this runs as expected, we are not actually calling this function. So if we call get random dog, actually, if I remember correctly, Objective-C function. I don't know why we have it as so one thing we can actually do, I don't know what, we'll go into that a little later. But let's run this. We're gonna call get random dog on startup. Why is this not showing up? Sorry, debugging some more. Oh, it actually did show up. Interesting. I don't know why it keeps. Sorry, I'm unclear as to where this is being called right now. Okay, I just found it. So actually we'll see that your starter code should have a timer object that is running every 3 seconds. And it just calls this function get random dog. It just repeats. But yeah, every 3 seconds we're going to be making a call to get random dog. And so that's why this is rendering. But you'll notice that like sometimes these are a little quicker, sometimes taking a little bit more time. This is all because the server responses, or the response time of the server requests, are all variable. This is something you just cannot rely on or like expect to be within like a certain number. But yeah, so we should have everything set up. To quickly recap, this dog function was very nested. So let's dive a little deeper into this really quickly. So from the view controller, we're just calling network manager get random dog, and we're expecting that this just returns an image. So the interface with this function just returns an image, and it's very simple. But what's happening a little deeper into the logic is it's calling one request to the dog endpoint, and that dog endpoint is returning us this URL, and from that we need to make a nested call, so a second call to that endpoint to retrieve the data, and so that's what this call is then doing. So it's calling fetch dog image, which then makes the second request using that URL and retrieves the data. And so this data is just a data object. This is how it's pretty much just bits and information that is used a little more internally. You can mess around with data objects a little more. But yeah, and then we're just passing that back up the chain through completion handlers. And so this completion gets run here, and then this completion gets run in view controller. And so yeah, that's I guess a pretty good recap on networking. I'm trying to think if there's anything else we can go over. I guess yeah, just to recap on the responses. Actually, let's go through a quick errored one just to highlight why this needs to be matching. You'll see here that what's happening here? I don't like this. Alright. You guys don't have to go through this code. I'm just highlighting some of the issues that could come about with the decoding. But you'll see here that this actually errored out. And this is most probably being caught in our network manager. We'll see here. You guys don't have to follow along for this part. I'm just, this is more like conceptual stuff. But if we actually run, sorry, this is in the wrong block. We want to improperly decode the course's data. And so the course's response is actually going to have an error because the course object has a mismatched key. This actually popped up. And so we have instructor in the data, but this is trying to decode a field called instructors. And so if we put a breakpoint here and see what exactly is happening, it calls this function and is trying to decode it, but it actually hits an error. Usually this data has a little bit more information on what's happening, but you'll see that it actually got an error. If we were to force unwrap this, then we would get the printed out error. But yeah, this is also a great reason why to do this as optional chaining. If for some reason the API were to change, or you had like just some small bug or mistake in like mismatched keys or whatever, this is a great way to catch it without breaking the app for any of your users. That's good. Yeah, I'm trying to think. I think that should be everything. Yeah, if we fix this, now we see that it should properly decode, and then it properly runs through this block. You'll see, so the completion handler. Yeah. Other than that, I don't think there was too much else I wanted to go over. But yeah, some, I guess, action items for the week. We have project 6 due by the end of this week. Is it project 6 or 7? Not 100% sure, but project is due Sunday as usual. And if you have any extension requests, just make sure it's within 24 hours. We have also updated the office hours sheet, and it'll be posted on the Piazza. But yeah, feel free to sign up for any of those slots. I guess try and keep the sign up within 24 hours before, or like more than 24 hours before the actual slot, just so it gives us more time to prepare. But yeah, thank you guys for tuning in. I hope the rest of you guys' week goes well. Thank you.